Artificial intelligence is making more and more of the big decisions in our lives. I'm talking about everything from whether you get a loan to even your medical diagnosis. And these systems, they're incredibly powerful. But there's this huge mystery at their core. How exactly do they come up with their answers? All right, let's dive into this. Let's peel back the layers on what we call AI explainability.
Okay, just imagine this for a second. You're at the doctor's office. An advanced AI system runs your data and flags you, says you have a high risk for a serious disease. Your first question, of course, is going to be, why? Right? What did it see? Was it my age? My weight? Something else I don't even know about?
And here's the really scary part. The answer, way too often, is, we don't actually know. The AI model is just so complex that even the people who built it can't fully trace the logic for that one specific prediction. This is what everyone's talking about when they mention the AI black box problem. The data goes in, an answer comes out, but what happens in the middle, it's a complete mystery.
So, if these systems are basically magic boxes, how can we ever really trust them with our lives, with our money? This is exactly where the idea of AI explainability comes into play. It's all about finding ways to peek inside that black box. And there are some really critical reasons why we need to do this. First off, it's about trust. Plain and simple, you just can't rely on a system you don't understand. Second, we need to find the flaws and biases. These complex models can sometimes pick up on, weird, unintended patterns from the data, and explainability helps us find those. It's also, of course, absolutely essential for debugging models while they're being built. And finally, you've got regulations. Think about it. Agencies like the FDA have to sign off on these things before they can be used in hospitals. They need to know how they work.
Okay, so when it comes to actually opening up this box, researchers basically take two big approaches. A great way to think about it is the difference between looking at the whole forest versus just examining one single tree. So, on one side, you've got what's called global interpretation. This is the forest view. It's trying to figure out the entire model's overall strategy. What are the big general rules it's learned? But then you have local interpretation. This is the single tree view, and it's exactly what we need for that medical diagnosis we were talking about. This approach doesn't care about the whole system. It just wants to explain one single prediction. Why did you get that result?
So, how in the world do we actually get these single tree explanations? Well, fortunately, some really clever people have developed tools to do just that. Let's take a look at two of the big ones.
First up, we've got a tool called Lime. Yeah, I know, the name's a bit of a mouthful, but the idea behind it is brilliant. Just think about it. If you have a mysterious black box, what's the first thing you do? You kind of poke it, right? See how it reacts. That's exactly what Lime does. It takes your one data point, say your medical file, and it creates thousands of tiny little variations of it. Then it asks the big complex model, hey, what do you think of this one? And this one, and this one. By watching how the predictions change with each little poke, Lime can build a much simpler, totally transparent model that basically mimics how the big black box is behaving for just that one specific case.
So let's break that down real quick. First, you pick the single prediction you want to understand. Easy enough? Second, Lime creates a whole bunch of new, slightly different samples that are super similar to your original one. Third, it runs all of those new samples through the black box to get new predictions. And fourth, and this is the really cool part, it takes all that new information and uses it to build a simple, easy-to-read model that tells you exactly which features mattered most for your specific outcome.
All right, the second big tool is called SHAP, and this one comes from a totally different place, game theory. Seriously, SHAP looks at a prediction like it's a team game. Every feature, your age, your weight, your blood pressure, is a player on the team, and the final score of the game, that's the AI's prediction. SHAP then uses this really clever method to figure out the exact contribution of each and every player to that final score. It answers the question, okay, how much did the age player help the score? And how much did the BMI player hurt it?
And this is where it all clicks. This isn't just some abstract theory. When researchers used SHAP on a well-known diabetes dataset, the result was crystal clear. It could tell a doctor, hey, this patient is at high risk, and here's exactly why. Their glucose level was the number one factor, followed by their BMI. Now that is something a doctor can actually work with. It's real, actionable information.
So when you put it all together, you can see how tools like Lime and SHAP are starting to completely change the game. We're talking about fundamentally altering the AI systems we interact with every single day.
Really, the whole point of all of this is transformation.
The goal is to move away from these opaque black boxes that just spit out answers with no explanation, and move toward what you could call transparent glass boxes. We want systems where we can actually see the gears turning, where we can question the logic, and, most importantly, where we can build the trust we need to use them safely and effectively.
And this whole movement toward transparency, it's a really powerful idea. It kind of makes you think, right? As AI and these complex algorithms weave their way into everything from our social media feeds to our courtrooms, you have to wonder, what's the next big black box that we absolutely have to crack open?